I would have to take from the root, from the core concepts, but we will add some clean stuff as we go on. Okay, let's start. So, who am I? I'm Victor Denta. I'm a consultant, a technical lead, an architect at IBM Romania. 11 years of experience. I would like to define myself as a clean code evangelist. You might know me already from other sessions. I'm really passionate about clean code and what it means to write clean, elegant code. In the free time, I speak at various conferences, but what I like to do most is to hold trainings for various companies, like on Spring, clean code, design patterns. I had actually the design patterns in the computer science department of Polytechnica for 4 years in a row at the CB series. Anyway. Also, I organize coding dojo for various companies as an independent trainer. Okay, you can find more on my website. So training is basically my passion. That's why I'm here. Why did you come to the session? Because lambdas are cool, right? Yeah, it's so cool. Yeah, lambdas, arrows, functional programming, all this stuff. Okay, but I mean, literally, it actually caused an increase in the popularity of Java. It can be measured like this. Yeah? It allows us to write more expressive code, but if we make it too short, it might become cryptic, right? You may know, some of you, that lambdas can look very, very ugly. And that's the point of the talk, actually, to understand how can we write lambdas, use the Java 8 features, but with measure, with responsibility, keeping the code simple. So in order to know what features can I use in my enterprise application, I organized a little Lambda study. That basically, there are a couple of examples that I asked the participants to rate how easy it is to read, to understand, or to change. This is the link if you want to participate yourself afterwards. The slides will be published after. Okay, so what we'll talk. There will be basically three workshops. These are more, let's say, start from zero, because we saw that there are some participants with not much of experience in Java 8. Researching streams, transforming streams, then what it means to clean some existing lambdas, and I will show you how you can clean up the code that used lambdas, and the summary at the end. On the table, you can find this domain model. It is basically the visual representation of the domain that we will use in our exercise. Right? It's a customer that has a list of orders. An order has multiple order lines. You can imagine multiple order lines, but each order has a product which can be bought multiple times. It has a count, right? If I want to buy 3 chairs, I will have an order line with chair, and the count equals 3, right? So it's just how many times, emag, increase the number of items that you want to buy. That's it, order line. Okay, now, if you know how to configure this, I will show you actually in the workshop. So we're talking about streams here, right? Streams are concerned about data processing, not about data storage. When you think about streams, you don't think about a list or a map or a set. It's just a stream of things that flows to you, right? No storage considerations there. Once you visited, once you saw an item out of the stream, you cannot rewind the stream and see it again. It's just like a river that flows, you cannot go back in time, right? So it's one way you cannot rewind the stream. And that's basically what we'll cover. So first, let's look for some items in a stream, right? No matter IDE, you use open up streams tests and search streams test. Do you guys in back see the code, or should I increase the font? Is it okay? Increase the font a bit? Okay. 1 second. Like this? Okay, the first problem. So before we start, actually, I'd like you to configure your Eclipse to be able to do the following. Pay attention to what I'm doing. ToList. When I write ToList, it automatically suggests to add a static import of the method ToList. Do you know what I mean here? In Eclipse, you should go to Window, Preferences, and here in the filter, type Favorite. And here you should add a new type, which is basically the collectors. So here, add the collectors. This collectors of the whole type. add this in order for us to be easier to type the actual code, right? So when you do that, give me a sign, or if it already works for you. Otherwise, you'll have to type all the time collectors dot. Can I continue? Okay, good. The first problem, I want to, so you have a test underneath, right? Here is the test, search streams test, it's named. It's right next to the file. And if we run this unit test, you will see that all the problems are failed currently, right? They all fail. Did you manage to see this?
Yeah.
Yeah?
Is there a project to check out?
Oh, if it hasn't have time to check out, please join a colleague of you who is here. I think both of you configured the project on the machine. Can you come and join them and write in pair with them? Because there is a stick, there is a USB stick that you can use. If you manage to import it, you can import it yourself. How do you like? So all the unit tests are now failed. So the first problem, I want this method to return the active orders of a customer. How could I do? So what I have here is customer get order stream, and then I'm collecting that stream in a list. Does any of you know how I can select only some items out of a stream? Filter. So once I have a stream, like here, I should do filter, right? And I will take it from scratch. I will assume you don't know lambdas at all, right? Let me play a bit. So I will write filter, and it requires me a predicate, which is an interface, right? Do you guys know how to implement anonymously an interface in Java? It's a bit ugly, but it's new, predicate of order. Two brackets. You remember we love Java, don't we? Huh? And then we need to import the predicate. Pay attention to import it from Java8 function package. Java8 function should be. One moment to start. Excuse me, 1 second. I have to start something that I forgot. I think this is it. You know, just for you to be able to follow my shortcuts, I wrote this little program that shows clearly the shortcuts that I use, the refactoring that I do. So for now, I will just import the predicate, and then I will add the unimplemented method. So hover over it, and it will tell you add unimplemented method, like this. Did you get to here? Okay, good. I want a lot of feedback from you, because I wouldn't like to keep asking you, keep stressing you. So tell me if you aren't able to keep the pace, right? So when should this predicate return true? It is given an order. When should it return true? When is? So the problem is get active orders. So it is active, right? So from T, which is the order, get status equals active. Does it make sense to you? Active. T status equals active. Okay, until now? It's all clear. Everybody understands these lines, right? Okay, let's make it a lambda, shall we? You see, in Java8, Java, the compiler, is able to figure it out that you are implementing an interface here. Because, you know, the filter is a predicate. So for Java, it's quite clear that you need to give it a predicate, right? So it's automatically, this bit of lines here, this bit of code is useless, can be deduced by Java. You see, in Java8, any interface that has just one method can be implemented using lambdas, right? Because Java is able to figure it out this part. So what I will do next, I will delete this part. It's clear for Java. I will put an arrow between the order T here. I will put an arrow between these, right? And I'll delete the extra bracket like this. And it works. And this is your first lambda. Congratulations, right? Okay, we can simplify it more. Operation takes a predicate of something of order. You can see something of order. So the order part is again obvious for the compiler, right? So because it is obvious for the compiler, we can delete this part also. See? It still works. And even Eclipse can figure it out that P is of type order. Then, in case your lambda only does a return, this part here is again useless and can be shortened. But you see, this is only syntactic sugar. This is only things that you can do in code to shorten your code, but the essence is still there. And this is a more compact lambda, right? Is it okay until now, right? I know there is a shorter form, some other alternatives maybe, but let's move on for now. Let's go for the second one. I want to return the order in the list of orders here that has the ID. Stop. What have we forgotten? Test. Run your test. P1 should now be green, right? Should be solved. Then coming back, I want to return from this list of orders only that order which has the given ID. You see? How can I do this? First of all, I will stream the orders. The code is here, began a bit. Orders.stream. Then what do I need to do next? I will filter those. So .filter. And then what predicate should I use? Can you write order, arrow, right? Lambda directly. Order, get ID, and then what? Never do equals with long. Never do that. Not equals. Not equals the order ID which I was given. Okay, so I filtered it. So in my stream of data, only this item is left, which is surely just one. What do I do next? Find first. So find first. The first match, which is the only match actually, should be returned to the user, right? And it should be it, right? I'm done. That's it. It should be done. But no. What happens? It gave me an optional. What the heck is an optional? For now, we will just do the worst mistake ever, and we will do get. If an optional is like a box in which there might be something. If you just get that thing out of the box, you might get back an exception. No such element exception if no value is present. So we just did get. Now, one little parenthesis. Why did we have two methods? Find. Yes. Sorry? Or you can use this present. We will come back to optional in a moment. But tell me, find first. Find first. Why find first and why find any? What's the difference between them? Horrible. No. No. You see, this stream, nobody said that can't be processed in parallel. Oh my God, what's that? So instead of stream, I could write parallel stream. What the heck is this? We won't go there, right? We won't go there. We won't go to distributing those lambdas on different nodes for optimization. We won't go to map reduce algorithms. No. We will just say that streams, in theory, could be parallelized on multiple cores or even sent to other machines, serialized and conveyed to some other nodes for processing like we do back at work. But for now, I just want streams. So it has to do with parallel streams, just in a nutshell. If you use a serial stream on one single thread, it makes no difference if you do find any or find first, right? So just that. Okay, next. First test, work. Good. Next one. I want to see if this customer has at least one order which is still active. What does any programmer do now? It will go back and it will copy the code, right? We shall copy the code. No. Let me copy it just for fun. I want to copy it here, right? I have this little. What can I add here to solve the problem? The simplest change. Size, perfect. So if size of this collect list is at least 1, then it should work, right? It does, indeed. P3, it's okay. We can do better, right? Don't tell me obviously, come on, no. We are in the streams and lambdas workshop, right? We should do something more stream stuff. Is empty or not is empty? Okay, I understood that. So I could put this and say here is empty, right? I can even count the numbers of items which are left in the stream. Pay attention, the count is a method of the stream. And if I do that, I get the count of elements which were left in the string. If there are more than one, okay, I've solved the problem. Does this work? Yes, it works. Does it make sense to you? I mean, can you follow the idea? Right now, it turns out that in fact, so many developers do this, and this is one of the things that you can improve dramatically. And I'll tell you how. Instead of filtering and then counting, do any of you know already the solution? Any match, perfect. Any match. You see, any match basically will return true or false. It's a terminal operation. It terminates the string completely. It returns a Boolean. It returns true in case at least one element in the string match this predicate. Otherwise, it returns false, right? Any match. It's Romanian, right? It's English. Any match. Simple. Now, tell me, when you copy code, what do? You have to somehow refactor. Don't repeat yourself. You know, it's one of the capital sins of programming to copy the code. But if you copy it, at least make it improve it a bit, right? How can we improve this bit of line? How can we improve this code? Any ideas from you? What can we do? To do what? Put it in this Boolean test, to put it in a function. Where? In the order. Why not? Let's do it from the getter. So what we're doing here, it is called Encapsulate Conditionals. When we take a Boolean test and put it in a method, it's named Encapsulating Conditionals. So I will take this line here, right? And I will go to the order. So open up the order class and add here a method which is named how? Obvious, right? And that's how your code should look, obvious. So this is status, and the function should return status equals status.active. Does it make sense to you? What I did, I just enriched a bit the class of the item. Why? To simplify what happens here, because now I can write what? T.is active. Cool. And there is yet another more simple form. For now, if you never saw it, just type after me. Instead of t arrow t dot, we will write order for dot is active. What the heck is this? We love Java. Huh? Order for dot is active. We will explain this in more detail in a couple of minutes. But for now, just type after me. No? Order for dot is active. The same. Now that I've optimized the code, that I've simplified the code, my conscience is clear, and I can just copy the same approach in the other place, right? So the same thing. This is basically a predicate. If you think of it a bit, this is a predicate. What the heck? It's a predicate, right? Whoa. We'll copy it here, and we'll simplify the code, and the code still works, hopefully. Yes. Is it okay until now? Tell me, if something is not clear 100%, it's a workshop. You're supposed to leave here with nothing remained unclear. You're supposed to leave this place understanding everything that we do. Yeah, but you see, it is no longer any duplication. If you look carefully, between those two, it's well, not the two. This is a filter, and this is any match. We don't have any duplication. But if it were, yes, it might make sense. Next one. An order can be returned in case it had no order lines, which were in special offer equals true. How can we write this? So order.getOrderLines.stream, and then what? So, this function should return true in case no order line here is special offer, right? It's a diagram, and from the order, it's get order lines. It's a list of order lines of that order. So I'm iterating over the lines, and what should I write here actually? We saw any match, right? How about non-match? If no order line matches the predicate, what predicate? Well, line, arrow, line, dot is special offer. Oh, we can simplify this even more using the for dot notation, right? And again, I will ask you to forgive me not to explain all this in detail, but just type after me, for dot is special offer. Does it make sense until now? We need to import the order line, of course. And there you go. It should now work. Cool until now? Tell me. If you, I don't have, I mean, change pairs. The one who writes, in theory, right? The exercise 1 is written by 1, exercise 2 by the companion, and so on, right? Now, what we saw, we were looking for some items, right? We used filter to filter the streams and to leave in the stream only the items which were interesting. Then we collected the result in a list. We gathered the stream in a bucket in a list, and there you go. These are your items, right? Then we, in case you wanted just to check if there is a particular item in that collection, that stream, we used any match, non-match, or all match, which are things that the function that returns basically a Boolean, right? They just look in the stream in the items of that stream, and it's something. Yes, tell me.
I have a question.
Yes.
If find the first element doesn't match the criteria, then we engage it.
Obvious question, right? If it's found one that violates the test, what the heck? Why to continue, right? So short circuiting. And there will be a slide that explains it in more detail, but for now, just take it for granted that lambdas have a tremendous performance impact. It works like shit. And I'll explain you why later on. For now, lambdas are a bad performance. No argue about that. But in this condition, however, it will terminate the execution in case it found an item. You can all find. You can all follow the idea, right? If none matches the predicate, in case I find one item that matches, why to look more? Stop, right? This means short circuiting. However, lambdas work are very non-performant. Stream operations are non-performant. But in case you distribute those lambdas on 10 machines, then you can actually achieve better performance by distributing the load, the computation. Think Spark. Think the cluster of nodes that are processing data in parallel. Right? But for now, we just leave that away. And we saw that in case we called filter, we got back. I mean, filter find first actually gave us back the item that we were interested in. Remember, I was looking by ID for a certain order. Remember, I was filtering by the test, then find first. This is also short-circuiting. The first match ends the processing. But what terrifies us most is that it gives us an optional. What the heck? By the way, these are the perceived complexity, the perceived difficulty of reading such constructs according to the Clean Lambda study that I've run. Okay, so this means trivial and this means horrifying, right? And these are not that ugly, you know? It's okay. Then optional. What the heck is an optional? An optional is the best underused Java8 feature. The thing is that you know what is the most frequent bug that we have? Long live. You know, there is an article on DZone that the author of null blames himself. Right? Null wasn't always there. Null wasn't always there. Somehow null appeared at some point. Right? For example, in Scala, I don't have any nulls. Right? Null is just a decision that you take when you do a programming language. We have null in Java. Oh, good. I think with the optional, you can reduce the incidence of such errors. So as a rule of thumb, right? Don't just get. If you do get, it will throw an exception to you. Just like it was a null pointer, it throws you an exception. Try to do or else. I will show you in a moment. Else, throw, if present, or even map. What the heck? I'm actually using. I used that 2 days ago. I'll explain a bit afterwards. The thing is, just when you work with optionals in your code, how many of you work with optionals? Actually use them in meta signature in Turtle. Cool. This is a guideline for you guys. Avoid taking optionals as parameters in methods. But whenever you somehow produce a null, wrap it in an optional and return an optional to your client. There is more to read about optional. There are references at the end. I wouldn't insist more because it's not. Okay, so this is the big picture. Now I want to select the best items out of the stream, right? And let's code. Oops. Well, okay, so moving on, I want to select the order with the maximum price. Therefore, I want to select from the list of orders of this customer the order which has the maximum total price. Does it make sense to you? Right? To see what, okay. how full the customer was. No, how can I say? So from the customer, get orders, stream. And by the way, I think you noticed any operation on a stream on a different line. Clean Lambda, right? Don't stack them. Don't format this like this, right? It's stuffs so many logic in a single line. It's awful, right? So each operation on a stream on a different line. So we are here. Sorry for the scroll. Now, customer get order stream. Then we do what? We should get the maximum item, right? Max. Okay, but max takes a comparator, right? Max takes a comparator. Let's implement a comparator like in the dark ages, right? So, new comparator of order. You will understand in a moment why is dark ages. So I'm maxing. I import the Java8 comparator, right? And then I'm hovering the mouse. Look, mouse programming, and I'm adding an implemented method. Right? Good. Tell me, how should this compare to orders? What should be returned here? O1 dot get price, obviously, compared to, it's a big decimal, it's money, right? Never doubles, always big decimal. Compared to O2 get total price. Cool. And after I do max, why doesn't it work? I mean, what the heck? It's done, right? What's the problem? Why doesn't it compile? Do you figure it out without looking at the exception? It gives me again optional. Hooray! It's a boy, right? It gives me an optional. What do I do with it? I do get, right? Of course. And we run the tests. We swan the tests. The first test for this method is true, but the second one is false. You can't read the text, but it says that get max price order when no orders should return a nothing, should return a null. How can I make it work? Or else. You know what or else is? You know the operator NVL from SQL? It's NVL. It gives you a default value for it. Okay, forget about it. No. Or else what? If there's nothing in the box, what should I return? Null. Null. The API says that I need to return a null here. I run the test, they are green. How cool. Then, how can we simplify this? Of course, we can do the same approach. This is an interface that I implemented anonymously inline, so Java can figure it out, all these details. So again, I will delete this bit. I'll do the same trick as before, right? Delete this bit, put an arrow in between, and delete the extra bracket. This is how you transform an anonymous interface implementation in a Lambda. There you go, you have a Lambda. It works. How can we simplify it more? Cut the order. We don't need the order. We don't need the return, actually. You can delete this bit here. And it's the same thing, syntactic sugar, remember. And we're done. We're so proud, right? No. There's a simpler form. Wait a second. So first of all, let's extract it. Extract it as a comparator. Get compares order. You don't need to do that for now. This bit, we can just look. I'm extracting a comparator. What I say in Java8 is that we can do the same by using what? Comparator.comparing of what? Of a key extractor. What the heck is a key extractor? It's basically extracts from the item of the string the thing that should be compared, right? So from an order, it returns back the order dot get total price. And does it make sense to you? Right? It basically does the same thing as the line above, only a bit shorter. And this I can simplify even more. How? What's the difference? So order for dot get total price without the parentheses, like this. I'm referencing the getter. The getter is a function that takes an order and returns. Oh my God, it's a function that takes an order and returns a big decimal. Whoa. But nevertheless, I can now simplify the code, remove the redundant bit. I have this. And if I inline this variable back, look how nice it looks. And if I configure the static imports with care, I can even write this. And now tell me if this isn't simpler than the first version. Oh, so there is no excuse for not using comparator comparing. So does it work? Yes, it does. Okay, so we are in exercise 5. Let me see where we are. Okay, get. Now, okay, let's get back to exercise number 2. If there are any kind of question, don't keep them for yourself, please. Okay. Second problem. We want, so it's a practice, it's a good practice wherever you ran over an optional not to do get. I told you it's an anti-pattern. Don't always do get. By the way, the whole session will be recorded. It's on YouTube. I'll put it public afterwards. So get, don't do get. Then we should do what? We should return here an optional, shall we? So find any gave me an option. Right? What I will change now is that like this. I'll return an optional. Let me just check quickly if null. Now let's take to number 5. Leave it as it is because the refactoring should be done here on 5. I want here to return an optional of the order first. So instead of doing or else null, instead of getting the null order, I will remove this part. Now it returns an optional of order. Right? Of course, my test won't compile anymore because I've changed the API. But it's a good practice to return the optional back to your client. Let's look at the tests and see if we can fix them easily. In P5, there is a line comment about, which is basically testing. I think I should told you more. What I need is not only to return the optional of order. I want to return an optional of the creation date of that order. Imagine that. So not only the optional of order, but I want, in case I found an order, to look into it and get the creation date. It's a requirement. It's a change request, right? We love change requests. That's the change that came to us. So we can do what? Map. Wait a second. Map. What does the map do? So for an optional, if you map using a function, you can transform from optional of order to optional of something else. Let me show you. So order get creation date. I'm using this function. You know how it feels? It's like you have a box, something inside. You apply some magic and you transform the thing inside in something else. In case there was nothing in, no null pointer exception occurs. You see? You're just transforming. Whatever was there, whatever was there, you transform it in something else. Right? And that's what you do. And you return this optional of local date. Behold the local date, right? You're still using the Java8 data. Me too. So let's switch to test and comment out the other lines for problem 5. So I comment about the other lines that were there. Now, let's see if it works. It does. So you see, for the test in which I gave the code and customer with no orders, the max didn't return anything, was an optional, was an empty optional, but my code didn't break with exceptions. Can you see? There is no exception going on because I used the map. I know it's hard. That's why it has some. There are difficulties in adopting of optionals. Okay, next exercise 6. But before 6, wait. P5, P6. Yes, here I want to give the last 3 orders sorted descending by creation date. The last 3 orders that were placed by the customer. So customer dot orders get orders dot stream. Until now, I knew what to write. What do I do now? I have a stream of data. I want to first sort it. Right? What do I want? I want to sort it. Okay, sort it. But you see, there are 2 options. Because orders aren't naturally comparable, they don't implement comparable, then I need to give it a comparator. How would I write a comparator? Comparator dot comparing. Then what? Order. Get creation date. Import the comparator, right? There you go. I've sorted the stream. I still have a stream of orders, right? Then what do I need to do next? I have to revert the comparator because it's descending, right? Right. This was the bug which I left there intentionally. So reversed. Reversed is the default method. What the hell would that be? But anyway, it matters that you can invoke another comparator to produce a different comparator, another instance of a comparator, which sorts the things backwards, right? And then what do I do next? I have to collect them to list, right? Right or not? No. No, why not? Why isn't it correct? What's the specification? Left 3 orders. And if I look at the test, I can easily, but I cannot see from there, but it returned me here 4 orders. If you run the test yourself, you see that you got back 4 orders and not 3. And the specification said we wanted just the last 3. How can we limit the string to only 3 items? We limit it, right? So we limit the string to 3. You know, the point is clean lambdas. Why? Readable code. I mean, kind of sorted, right? Limit. It's human readable. That's what I like about lambdas. Not being geeky and writing weird stuff that only I understand. It's not the purpose in enterprise applications. The purpose is that your child can understand it, right? Good. So this is all done. Are we done until now? Can I move on to the back to the slides? Okay. Tell me in case you want to wait a bit. To where we were. What we did now, we transformed the items. No, sorry. We selected the best one using max of a comparator, right? But the problem with max is that it gave us back an optional again, and we had to understand what the hell happened with that optional. Then, in case we wanted several best items, we needed to use sorted limit, right? Sorted and then limit. And by the way, limit returns only the 3 items, for example. Skip allows you to skip the first 3 items. Yeah. Anyway. Then, on all these cases, I found very handy to have comparator.comparing of a certain extractor, key extractor. Okay, but what I didn't show you yet is that I can change the comparator. You know, the school record, it was renta, and then there were 2 renta. They were sorted by the first name, right? You know the concept, right? Sort first by a criteria and then by another criteria. What I mean here is that after this comparator, I can write dot and then comparing another key extractor. For example, order get total price. You see what I mean? I can change the comparators, but once I do this, this is ugly code. Why? I broke the line. So what do I do? I'll extract this bit in a variable, explanatory variable. I'm talking clean code here. So I will extract a local variable. The shortcut is above here. Alt-Shift-L. Or a function, yeah, in Eclipse, it's Control-Alt-V. This, how would I name this bit of thing? What's this? It's creation date, descending, right? How about that? It's a comparator that allows me to stick all the code on one line. It's easier to read this way, right? So always don't just leave the lambdas there as they resulted. Always read them again and see if they are clean enough. And don't do multiple rows. Don't enter. Extract local variables above that allow you to group the entire expression on one line. Okay, good. And what we'll do now is basically to transform the items. Okay, let's switch to another one, to the other class named transformed streams test and transformed streams, the other 2 classes there. Transform streams and transform streams test. And I will already run the transform streams test, and I see that the first method actually passes, right? So in the transform streams class, in the transform streams class, I have this little bit of logic. You all recognize it, right? It transforms the list of something in a list of something else, right? Now tell me, what's the useful code here? What is the code that actually matters? These three, right? The rest is, I wouldn't express myself. So what I'll do next is basically I'll try to leave this in place, but I'll try to cut the things and use Lambda instead. How would I do that? So let's try to, first of all, what is the operation that I will use? What's the function that I'll use? Map, of course. So orders.stream, and then .map. And it requires me a function, it's not readable from there, that a function that takes an order and returns something else, right? Transforms the item. So basically what this needs is a lambda, right? Let's write it first as a lambda. It's like this. And I will just copy, pay attention what I do. I copy the useful code from here to here, inside. And map has the following complex. We give it an order, and in turn, it has to return you that another object of a different type. So what I need to do here, to return the BTO, of course. I have now a streams of BTOs, right? That's a bit. I need to collect them into a list. Collect them to list. Right? Do you agree with me until now? Okay. And to list, I think it has to be. That's why I said that I wanted you to have static imports by default. Just to write to list. If you write collectors dot to list, you're lost. So to list. And I simply return this list. Let's see if the test works. It doesn't compile. I'll comment this out, and I'll run it again. It still works. Good. Now tell me, let's play a bit. Now the funny part begins, right? So what is this actually? It's a function from order to order DTO. Let's see it. It's a function from order to order DTO. You see? Interesting. It's a function. Now it's a hard point. How can I get you there? First of all, let's leave it as it was. And extract a method from this part. This is the useful bit of information. This is the interesting part. I'll extract a method. Named how? How should this be named? Order to the tail, too long. To the tail. Because order, you see the signature, it already has an order. Right? To the tail, perhaps. And it looks like this. And now let's simplify. We'll use inline. Inline. We will drop the return, okay? And we will end up here. Now tell me, is there any way to simplify it even more? How? Move the method to DTO into what? Do you all agree it's good to put in the order entity the mapper? No, into a new class. Okay. Into a new class and make it somehow static. But suppose that it's just static here, the same thing, syntactically, the same thing. It's a static method, right? This should work, right? Then method reference from what class? From this one. Ooh la la. And let's see where we get from here. Ooh. Wait a second. Until now we use method references for getters, right? But this is no getter. This is the not a factory method, whatever you want. But let's suppose for a moment that you can't do this because at some point you use some order repository, which is a dependency injected using auto-wire, using blah, blah, blah. You cannot make it a static method. What would you do then? So no statics. How can you reference this method? Huh? Ooh, this. And it's the first time we see how we take a method reference out of an actual existing instance. Damn it, it's an existing instance. This is an instance. If you don't believe me, you should believe me, but still, transform streams. You know, you love JavaScript, self, because this, right? and then self for that. Cool. But what if we wanted to reference the method? And furthermore, what is the signature of this method? If you extract it, it's a function. Again, it's the same function from order to order DTO. Agree? Now, try to play with me. What happens in case I reference this method not from the instance, but from the class? It requires it to give the actual, so let's think a bit. If you take this function, you put it in a pocket, right? Go away, then you come back, and you want to call this function. What must you provide this function? First, of course, you need to give it the parameter, right? Sure. But you also need to give the instance to which to apply that function. Does it make sense to you? If you know reflection, if you know Java.apply on functions in Java, the same thing. You need to give it the instance on which to work. Therefore, this actually, it's a B function. What the heck was that? It's a B function from transform streams, comma, and that's it. Now it might work, but it isn't what I need here, right? It's a B function. There is no tree function, by the way. If you want tree function, you should import some library, Joule or Java Slang. For now, let's go with this. And there is more yet. But until now, if it's clear for everybody, it shouldn't be clear for everybody. There will be some slides. But for now, one more play. Let's suppose it's not this, but I'm creating a mapper class to transform from one object to another. So let's pretend we have a wire here. And we have a private order mapper. You don't need to read right after me. I'm just playing a bit. And I have this order mapper class containing like this. Like this, it basically contains this function. Suppose it is a different file, right? Yeah. Then I'm auto wiring it, right? Then I can write mapper, and this is exactly what I do. And let me tell you exactly what it looks for me. I'm now in line. I'll just copy this bit over here. And this is how my transformation of the entities to DTOs work. And for this particular use case, I find even fine to collapse it in a single line. It's too easy to not understand, right? This is how my code in production looks. It's clean, it can be understood in one fraction of a second, is no problem. All clear? Shouldn't be all clear, right? Method reference. So you see, order creation date, it's a getter. It's a function that takes the instance and returns the date, right? Right. Then, order mapper to DTO, I'm referencing this instance method of this class, right? What should I give this function? First of all, the element to map, of course. And yet, the instance of mapper, you see? It's a function that takes the order mapper, then the order that I pass to the function, and gives back an order DTO. Does it make sense to you? The first method, the first parameter is actually the instance on which I want to apply the function. Then, this is an instance method when I reference it from math. But we saw together we can reference the same method from an existing instance. From the order mapper, which is a field, a variable, I am taking the toDTO function, which now has what signature? It's f of, I don't need to pass this one anymore. It's an order. Only the order I need to pass. It's not easy. This part is not easy, but you have to learn it if you want to write expressive clean code. So f of order mapper, comma, order. This is no longer required if you specify the instance when you got the reference to the method. It's only, this is the signature that means. For this one, if I get it from an order, what is the signature? No arguments are required to give me back a date. True? Cool. Now tell me, for string length and string length, what is the signature here? The length, you know the length method of a string. Okay. What does it need to work? Here I have to have one argument, the string, But here, it isn't required because I already specified the instance here. Again, it's not easy. This part is not easy at all. But still, there is more. I can even reference static methods. Tell me, what is the signature of this method? Do you remember this method? There once was a method named parseInt. What does it do? What does it do? What's that? In fact, in kindergarten, we learned that it takes a string to give me an integer back, right? What's the signature? F, string, and returns an int, right? Cool. This is a static method. And there is yet more. Behold, sorry, one moment, hide. Here it is. Date new. What the heck is this? What does this mean? It can be a function that takes nothing and returns the date. Remember, new date, parentheses, parentheses, takes nothing and gives you a date for now. A bad mistake, local time zone, blah. But it also has another constructor which takes a long and returns you the date. Right? So this can be custom to a type of that function or a type of that function. How I decide, right? Referencing constructors. I even do that in production code. It's weird, I know. Okay, so this is the Lambda syntax. You have it yourself, I think. This is what? A function that takes a string, returns an integer, right? Simple. This is a shorter form. It's a function from string to integer, right? By the way, Java 8 functional interfaces. Functional means the first argument is the type of the argument, right? The second one is the return type. We love generics, right? String integer, return. String integer. Next, this or even this, right? Then comparator. Don't do that. Try this one, right? I'm referencing the getter of the user. Right? Okay, then it is when a function takes an apple and returns true or false, it's basically a predicate in Java 8. A predicate, right? True or not. You know? Who do you think will won the elections this year in Romania? Radio Erevan. True. Another set of jokes, right? So anything you give it, it tells you true or false. Right? I can even go further and create a method inside the object, inside the apple. I dig into the apple and put a method there, and then reference the method from inside the apple. Right? When something takes a string and returns nothing back, it's a consumer. And arguably, string arrow system out print, this returns void, right? Returns nothing in turn. So it's like I don't know, a black hole. You know, you throw things, you know, the /nil, the dev nil. How many passwords were thrown up to that black hole? Eh? Then, behold this one, system out. By the way, when the something is italic and bold, it means it's a static member. Right? So static, this is a variable. This is actually an instance, right? So from this instance, I take the print line function. Oh my God. And you will see this in examples using Lambda. Right? And this is the first miracle. Right? From nothing, behold wine. Well, actually, it was water, right? Spring water, something. But from nothing, there was wine, right? So this is something that from nothing is able to produce things. It's a supplier in Java 8, right? Wine new. So this was what he did, right? Wine new. Okay. It was water. Yes, it was spring water. I'm cheating. Okay, back here. So we are at exercise 1 yet. Let's move for the next one. I want to collect in a set where in 5 minutes or 6 minutes, there is a funny clip going on. Coming up, right? It's here. Yeah, I'll put something to brain break. Whatever. So here, I want to get a set of payment methods out of the list of orders of this customer. So first of all, from customer, I will get the orders. I will stream them. Okay, this I'll know how to write. What should I do next? What we always did until now. Dot collect to list. The same thing. Dot collect to list. Right? Great. Now, this returns me what? A list, of course, right? I asked for a list. Okay, could it be there a toSet method? Oh, nice. Problem solved. Right? No. What I forgot to do? Look at the requirement. Get the payment method. I need to return a set of payment methods. So I have a stream of orders. I need to transform that stream into a stream of payment methods. Map. What? Once again. To what? Order. Get payment method. Problem 2 is solve a problem 1 no longer works. It returns me a null pointer. Why? Not sure. It returns a null pointer. What the heck? But was it what? Ah, the bottom up. Yes, right. Sure. I mean, injecting independence. Okay, so it's all green. The next method, get order dates ascending. I want to see the dates that the customer placed orders sorted ascending. First of all, from the customer, I get the orders, I stream them, then I do what? I have to return a sorted set of local date. What the heck? Sorted set, right? Of a set with a sorted. Lovely. So first of all, how do I get to the local date?
Order dots.
Yes, order for dots, then
Get
date something. Get date, and Eclipse is smart enough to get creation. Yes, okay. And then what? Collect. No, not sort. Don't need to sort anything. I mean, we will collect into a collection which is by itself sorted. You don't need to sort it beforehand. If you put stuff in a sorted set, they will be sorted, right? That's why it's a tree set, right? So for now, if I write to set, it won't work because it returns me a set of local date, not a sorted set. You see? I need a sorted set. Can you give me an example of a sorted set? Tree set. So what should we? So it turns out that apart from toList and toSet, we have two collections, rarely used though, that I can give to Java the constructor of a collection. For instance, how about that? Preset for dot new. This is, by the way, what's this? If we will extract it, what will we see? What's this signature? What's this actually? A supplier. You know, new wine is a supplier of something. Given nothing, it's identical how I would write like this. From nothing, you see, from nothing, I instantiate new tree set. Same thing, right? Okay, so this bit is identical to saying tree set for dot new. Okay until now? Okay. Rumors. Next one. I want to return, so from the orders of a customer, I have the orders of a customer. I want to return, pay attention, it's tricky. I want to return a map between the ID and the order. Right? So ID and order. Right? This works because the ID is the primary key of the order. And the entries will not conflict. Can you follow? It works. It should work in theory. So what do I need? So from customer, get orders, and then collect. And what do I need? A map, right? A map should be two map. Why not? But two map, it turns out it takes two parameters: key mapper and value mapper. Imagine the following picture. You have a stream of objects coming in. Right? From each object, you take it, you look at it, you extract a key from it, you extract a value from it, and you put the key value in the map. Does it make sense here? Okay. What's the key for this? Order ID, exactly. And as method references directly, right? Order, get ID, right? I should have told you by now that I hate Lambda. Do you see any lambda here? Not a lambda, it's a method reference. That's my point. I don't see any arrow. I hate arrows. And if I really have to have an arrow, I only have one-liners, always, as the hard rule. If I would start saying I hate lambda streams or left, right? Now you understand why, because it's more readable to have it like this. It's more readable, get payment. Oh no, it's tricky, the construct, it's a bit weird, okay, I know. But in the end, it's all more clear. And what should I write here? What is the value mapper? So I have one order. What is the value? The actual order. Let's write intelligent code. Order. And I'm happy with me, right? I'm programming. To spare me from such, I don't know how to express myself. There is this function identity. Function identity. Come on. But it's optional to use it. It's a bit weird to use such a thing. You can static import, but what I prefer to do is something like oh. Come on. Anyway, you got the picture, right? From this order, I extract the same order, right? The next one, before the movie break, get products by payment method. Woohoo! This is a hard one. You can check the domain in the meantime. So you have these orders, and each order has a payment method. What I want from you to give me, it's a map from payment method to all the orders that use that payment method. You see? So group by in SQL. Right? Let's write. So customer, orders, stream, and then what? I need to collect first. By the way, you will see in a moment what I mean by collect. Always I collect to kill the stream. When I collect, I get something in return, something which is no longer streaming, right? It's a bucket. It's a bucket of something. Collect to what? Grouping. Not to map, because if you do to map, the key will conflict, right? There will be multiple orders with the same payment method, and you will kill yourself. So it's grouping by. And the classifier. What's the classifier? It's something that takes the order and returns back the key by which you want to group them. We are talking hardcore stuff here, but you are grouping orders by some key. What is the key? Exactly. What am I doing? Exactly. Oh, cool. Right? Good. Now, time for the most expected, right? Do you want a horror or not? A horror movie. Horror? Horror. Se vede per la parte del testo?
Has a dark history. Ja, vi stannar så kan man kanske gå till landet. Ja, det är postkontoret när vi bygger här. That gift is called the stream. It's a gift that enables you to communicate with other beings around the entire world. It's a gift. And some persons are forbidden for a reason. That's one. Great. And go play. Extractor, teleport. You go. Forward. Check. Exception. It's more demanding than it appeared to be. May I read Lord Shadow, wisely directs. Whatever how you as robotics sports of you, feeding with fox in them for the
Coffee.
Your object, the stream.
Okay. Okay. Good. Yeah. Well, better, right? Okay. Good. Let. It might be a bit out of, but anyway. Excuse me in case. Access blood. Anyway. Coming back to streaming, right? To streams. Let's go for a harder one. I have this list of order lines. Well, you know this problem. You look at the code here. Customer has a list of orders, and each order in turn has its own children order lines, right? What I need to do now is to collect all the order lines for the customer in his entire history together in one single huge list, right? Just like in Union, not Union, but something like this. So I'm iterating over all the orders of the customer, and for all other lines, I'm adding to the new list all lines. You see? I'm joining all the children together. Okay. Then what I need to do next is to get the sum of all the counts for the same. So basically, the question is, how many products of each type has the customer bought in his entire history? Therefore, I need to sum the count attribute of the order line. For example, look at the test to get a better picture. The test for this method looks like this. This guy ordered once 3 chairs, and another time 1 table and 1 additional chair. In total, I should return 4 chairs and 1 table, right? To sum the counts for, you can imagine, right? It's a hard one. Okay. So first of all, I collected already all the order lines together in one huge list. I need to iterate over that list stream. And what do I need to do? Let's imagine a bit. So I have these order lines, each with his product and an attribute count. What do I need to do? And here is the keyword. That's the same thing, right? And it's still okay. Grouping by. So I will again collect grouping by what? By order line. Pay attention. I have order lines here, right? Exactly. Or exactly. Get product. What does this give me back? Let's make it a variable. What it gives me back? A product of a map from list to list, right? From product to list of order lines. I don't need that. I need something else. I need to sum up all the counts for all the order lines. Let me try something. Instead of, you see, get product, I mean, grouping by can have additional parameters given. And the parameter that you supply next is another collector. Pay attention. It's another collector. This, again, was a collector. And now I'm passing another collector. Let's say counting. Counting, what will return? Let us see. First of all, it will basically count all the number of items in each group. Right? I grouped by product, and then I'm counting how many order lines are there. And let's return this one. Should it work? Do you think it will work? Let's see. I expected, I'll read for you. I expected that there are 4 chairs, but actual result that was given by this function is that 2 chairs. What I just did, I just counted the order lines for the chair, and indeed there are 2 order lines, but I don't need to return the number of order lines. I need to return the total items, right? For this purpose, I have the count attribute inside the order line. So what I need to do is to sum up, summing long. I'm summarizing the keys. What keys? Things will go rampage soon, but here, what should I sum? Order line. What? Get count, exactly. And again, I have a nightmare. I have remorses to create this. And what doesn't work? Map. I wrote summarizing. Incorrect. Summing long. It's a different function. Summing long. And there you go. That's your answer. It works. Imagine what I did. I grouped first order lines by product, have different buckets. Then for each bucket in turn, I summed their count attributes together, right? Count of the first order item, count for the second order item, summing these items together. Okay, are we true? Not by far. You see this, but until now, is it clear what we're doing here? Next, this task of joining the children of my children, joining my nephew, my grandchildren together on a family dinner. Right? This task is so common that was actually added in the options for the stream. Does anyone of you know how to do it already? Okay, so all lines equals customer dot get orders dot stream, and then it's called flat map. Oh, you see the rumors. And it's with purpose. I'll explain. It's one of the features which is hard to grasp. It has to do with monads. Oh, sorry. Flat map of what? So this flat map, what does it require out of me? It's a function that, given an order, will return me a stream of children. A stream of children. So how do I get the stream of order lines? Order, get order lines, or stream. Even I can write, right? I mean, sorry. Pride, right? Okay, and then what? I got, so this basically return me a stream of order lines, right? What do I do next? Collect. Collect. When you don't know what to do, you collect. Okay, and I say that this is similar. It still works. Flat map. Ooh la la. So you see, it's a bit shorter than this. Let's cut the bit and leave only this part. Right? Flat map, if you don't know what flat map is, it's unreadable, of course. But if you know what flat map is, it makes sense. I'm grouping the children. But I agree with you, it's one of the features which is not immediate, which is not very trivial. I mean, you can, yeah, it's a flat map, not that easy. But now I will even inline this variable more here. But when I do that, I see this. I have a stream of order lines, I'm collecting them, and then I'm streaming it again. Why? Right? You see what I mean? Yeah. It's useless. And there you go. There are 2 lines. If you're implemented in Java 7, 10, 12 lines at least. And arguably, it's more readable even. I'm flattening the children, then I'm collecting, grouping by product, and summing the counts of each product line. Okay, next one. I want to get all the products that were ever bought by this customer in a single list, unique and sorted. Let's take it step by step. How do I get to the product from the customer? How do I get to the product? Look at the model. Anyway. Get orders stream. Okay. Then what? Map. From what?
Order, get order lines.
Okay. What's this? First, one thing that you can do while you're still learning Lambda, is to always see what you got back. Are you happy with what I got back?
No.
Flat map. You got a stream of list of children, whereas you wanted to join, to concatenate those children. It's a flat map. By the way, where is it? Here. So you have your items, each has its own children, right? Flat map, what it does, it just concatenates all the children together. That's it. Joining your children in a new stream, right?
But doesn't it also apply the function on
the function which is applied? So let's.
Is it applied just once or applies it until?
For each item applies the function you should specify, but the function should return a stream of something. That's the trick. It's also transforming, but transforming from another stream. So now I have this stream of lists. How can I go further? It's tricky. Let me try. So again, I need flatmap, of course, flatmap. But how? And check this out. I never did that in my rehearsal, but what about list stream? What the heck am I doing here? Does it make sense to you what I did? Is it correct? I got a stream of lists, and then I streamed each list. Okay, sorry. Let's write it. So this is one way of doing it, but the more readable way, in my opinion, is to have flat map directly, and to say from each order, I want order, get order lines, stream. It's a bit more readable, perhaps. No, with time, perhaps you will prefer the first option. Then what? I get now a stream of order lines. What do I need to do next? By mapping using what? Why flat map? You don't need flat map here. One order line has one product. You see, you're going to one product. So you're just transforming. If you have any kind of issues, tell me if I can help. Okay. I saw some busy people. Perhaps they're order line, get product. Right? Now I have here, this returns me a stream of product. What do I need to do next? I need to have unique product. Unique. What is the operator? Distinct, right? That's it. Distinct, using equals. And then what? Okay. List. I missed one bit of the specification. This should be returned directly. I missed one bit. Sorted. I missed the sorted part. So I need, after distinct or before, to do a sorted. And I need to sort the products by what? By compare, because they are not naturally sortable. And by what criteria do I want to sort them? Name. So tell me. Comparing of product get name. In my opinion, it's a bit too much. There are too many steps. That's another point that you should have in mind. Don't chain several operations of a stream. Break it once, collect things, and then stream them again in another method. It's maybe too much to understand this bit. Perhaps. I don't know. Okay, is it clear until now? 100%? Okay. The difference between a talk and a workshop is that you should leave here with everything crystal clear, right? In talks, you may nod your head, laugh, and then walk away. Okay, but in a workshop, that's the point. Right? Next one, get names of all the products bought by the customer, sorted, then concatenated by comma. Hint, reuse the previous function. What did the previous function do? We got all the products sorted by name. It's the same thing, right? So let's call the previous method P07 of customer. That it returns me back a list of products. True? Limit, yes. And then what? I need to get the names of the products and join them together. Come on. Who is it? Collect. By what collector? Joining, yes, of course. But joining allows me to give a delimiter, right? Like this? It doesn't work. Why? Collect requires the stream to be a stream of strings before collecting it. You need a map first to extract the name out of each product. You see? So here, map to string. Well, not to string. It's, by the way, don't ever use toString for business purposes, for logic. toString is only for debug. Never ever do bit logic or interesting things. The format for CSV export to toString, never. Write a dedicated function. So not toString. It's actually, I want to map by product, get name. Exactly. Now it works. Okay, joining. How cool. Next one. Next one is a tricky one. Do you know about folding in functional programming? Yes. Problem. You know, okay. We will see how it happens. But first of all, the requirement is this. I want to sum all the total prices of all the orders of this customer together. But you see, the prices are in big decimal, of course. They are money. So customer orders, oops, get orders stream. And then what do I do? Well, sum, right? I mean, what do you mean sum? Sorry? Reduce, but let's get there step by step. First of all, I want to have sum, right? Sum. Why don't I have sum? Because imagine you have a list of cows. How do you sum two cows together? Cannot, right? Two chairs. How do you sum two chairs? The string can be of anything, right? Of object. So on stream of object, there is no sum method, it's obvious, right? But, however, there is this thing named long stream. Ooh, what the heck is this? Stream we saw, but long stream, what is it? It's a stream of longs, right? Which actually has an interesting method, sum. Ooh, how convenient, right? From a stream of numbers, you can sum them. That's obvious. How do I get to a long stream? That's my question now. So you know about the map method, but you don't know yet about map to long method. Map to long takes a function that from an order returns back a long, right? So I can do this order dot get total price dot long value. From big decimal, I'm getting the long, and then I have this is basically a long stream. True? And I can do sum. So green. I can run for coffee. Right? First of all, this is not. I can do better than this. I can do map. Let me show you. Dot map. But this is optional. I don't say that this is a better approach. Get total price, right? And then I ended up with big decimal arrow. You see what I'm doing? And then I can even do more. I hate lambda. I don't say that this is way better or even better. Just another way. Good. It still works. But now I have a different. You see, I was summing here 1 million orders. And the rounding that I did when I truncated to long actually started to count. Therefore, I don't want anymore to truncate to long, but I want to sum the big decimals together as they are. It's big decimals, not to lose the precision. You can figure it out, right? The decimals. So how can I do that? I folded. What the heck is folding? Folding is quite simple, actually. you have this little stream of things, whatever they are, and you start with a seed with an initial value, and then from that value and the first item, you apply the plus, you get 2. Then from the new value and the next item, you apply the fold plus 6, 7, 10. So starting, given an initial value and an operator, you can fold the stream. You can see what I did? What I did? Tick, 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 just like summing two numbers in first grade, you know? The same idea. Folding. Reduce of 0 and plus. Ooh la la. How could that go? Reduce 0 and plus. No, I'm kidding. Although you might have expected, right? Java changed so much that it couldn't be. But for, what is 0 in big decimal? 0. Okay. What is the plus in big decimal? So the operator plus takes 2 big decimals and returns back what? The sum. And you can do the sum BD1 add BD2. Now, what I get back from this? A big decimal. I need to cast the truncate hit only here, but I'm truncating here, not all the way. So the error is way smaller. Question for Olympics: can I use math method references here? Big decimal. First of all, add is an instance method of a big decimal. What is the signature if you extract it as a function? You already see the. It's not obvious, sorry, but I need to write it. Big decimal. Sorry, B function. It can be a function from big decimal 1, which is the instance that I need, then the big decimal that I give parameter to it, and the big decimal that I return in turn. And this is basically the add operator, which is big decimal add. You see? It's horror. Okay. It's horror, but it works. I mean, what the heck? So here I can write this bit. Voila. And now it's almost as in the slide, right? 0 and plus. That's it. Folding. We can do way more complex things here, but it's not the purpose for now. We can compose in different ways the items together. Okay. Let's turn back to slide a bit. Where we were, what we did now, we did map. We saw that it's good to pull the mappings in a dedicated method and put the method even in a different mapper, somewhere else. However, don't use long lambdas. Extract methods and reference them by name, because this way you got the chance to putting a name to that thing. Yeah? You name the functionality. So prefer to use suggestive names. I don't know. 60% of what clean code means to choose good names. You know the say there are only 2 things hard in programming. Cache invalidation, distributed caching, cache trashing, and naming things. Right? So naming things isn't as trivial as it might look. No, when you have the chance to putting a name, do your best to select the best possible. On this zone, here's a guy which says that he looked for a name 4 hours. 4 goddamn hours he looked for how to name a class. In thesaurus, but the point is he was starting a new application. But at the end of the 4 hours, his entire design was clear in his head. Because by checking out all the possible meanings of that word, he understood all sorts of references to other concepts. So when the time at the end, he took the name, he solved the entire application. So look for, I don't say you should put your Jira ticket, look for a name, 4 hours. No. I feel that when you get the chance of putting a name, do your best to find a good name, a suggestive name, right? Clean code book, you should have the, you know the clean code book, the Bible? Yeah. Uncle Bob, you should sleep on it. You should have it, you should put it on your wall like this. You know? Every new hire should have a task in Jira. Read clean book, estimated time, 1 week. Okay, map. We also heard about flat map. Don't mind about that. Then we collected it maybe to a list, maybe to a set, and we also saw that we could collect to set, or we could distinct each item. There's a very slight difference, but there is. I shouldn't tell you that, but anyway. A hash set checks equality using hash code equals. Distinct only uses equals. Whatever that means. Okay, collection of something different, a different collection, my weird graph, my tree set, blah, blah, blah. I can collect even to a map in case I want to create a map from ID to the object, in case I'm grouping by a primary key, in case I'm not grouping by a primary key. Come on, click. In case I'm not grouping by a primary key, entries will conflict. Therefore, what I will get back is basically a map between key and a list of items, you see? Because for each payment method, there were multiple orders, remember? So group those together. And if you only do grouping by key extractor, you get back by default a list of children. But you can go further, and you can, after the key extractor, you can put another collector. What the heck? You can to set the groups together. You can to list, you can count them, you can sum them, you can even group them by another criteria. And I will stop now. The point is that we also saw joining using comma, right? We joined the stream of streams together. Then we also heard about numeric streams, right? That have sum, to which you get by mapping to long, to float, to whatever it is, right? And we also get a feeling of what custom folding means, right? Start from 0 plus first, plus second, plus third. Okay, that's basically what's on the chart. For the for each, I wouldn't mention a word. Don't use for each. Okay, some could step up and leave the room. According to what the study told me, almost everyone considered it easier to understand and to change of classic for each, you know, for the standard Java 5 for. It's simpler to read, right? And by the way, I should have showed you something. This is not the very first idea which I get if I want to solve this problem. I could have another approach. Excuse my boldness, but I could, for each, what the heck? For each of them, right? For each big desk, for each what? For each order, do something. What? What am I going to do? Guys, we'll leave the room. What are you doing? You are breaking the code. What the heck are you doing? It should be along at least. Or are you madman? What are you doing? Why doesn't it work?
Because you should modify something like this.
Do you have any idea how hard this is? And why? Tell me why. Now my question, do you want me to tell you why? No. Manipulation. This is manipulation. The point is, how can I tell you? Where this variable lives in memory? I hear stack, and not stack overflow. Stack trace, stack frame, right? Stack frame. The stack frame of the method. When the method exits, the stack frame is cleared away, right? Right. So what would happen in case let me I'll write another function. So let me give you a runnable public runnable incrementer, right? Which does the following: int x equals 0, return, and this is runnable, by the way. This is the simplest lambda you can ever write. This is a lambda. It's implementing the run method of the runnable. Takes nothing, returns nothing. And inside, I do x++, of course. And here, I invoke the method make incrementer. I'm getting back the runnable, true? And I invoke it 2 times. Anyway, this is called higher order function. A function which returns another function is basically a higher order function. Okay, and now tell me, when I invoke this method, it's all fine. I reference here the value, it's all fine. I exit the stack frame of this method, it's thrown away along with the memory address of x, true? And then I come and say run in plus plus, what? Plus plus on what? is no longer there. The memory address was just freed away because you referenced a variable which was on stack. Don't ask me what is stack, by the way. You're at the conference, I think you know what the stack is, right? So the stack is gone. And you reference what, you see? However, if you make it a field, oh nice, it still works, right? It's a field. I'm incrementing, and the object still exists. But however, I can do this. And this works despite, I mean, it's a bit confusing. We are referencing what here? You see, this value literally is taken away together with the lambda. It's some kind of closure. When you design a language, for example, in JavaScript, X++ works. It leads to lovely memory leaks. But anyway, this still working. So Java language designers had the decision to make, and they chose not to allow closures to modify the variables from the closure of the lambda. Therefore, you can reference other values only read-only. You can't change them anymore. Okay, now, in case you didn't understand what I said, what the hell I was talking for the last 5 minutes, don't mind. Just know that you cannot modify a local variable from inside the method in which you created the lambda. End of story. Effectively, no. Effectively, that had to do with concurrency. I'm a single-threaded here. No, it's so it is called effectively operation. Any variable which is any external variable which is defined, which is referenced here, is effectively final. Anyway, just that you know what the interview is, you know, when you sorry, no, they won't compile. It read. I mean, it's just screams. Okay, we got a compile error, fortunately. Okay, so this is about for each, right? For circuiting, it's time to dive more and understand more things. Let's say you streamed the orders, you filtered only the active one, and you mapped them, you extracted the creation date out of each order. What will happen at runtime? Well, you have a stream of orders. Then, when you call this method, nothing happens. When you call filter, nothing happens at that moment. Nothing happens. If you put a breakpoint, you pass a breakpoint, no item will be seen. Nothing happens. But when you reach the collect, which is a terminal operation, this will ask an item up. Give me. This will say, from where? I have empty pockets. Give me. Give me. It gives the initial list, let's say, gives the filter the first item, but this doesn't match the predicate. So the filter asks again, give me more. Give me more, yes. Gives another item. But this one passes the test. And the filter returns it back to the map, which transforms to date, and which gives back to collector, which puts it in the list. What should do the collector next? Ask for more, right? And the same flow again. And then again. Did that no match, then again. Now, let's think about performance. Let's think about performance. How many invocations to get 3 damn elements in the list? Said 12 invocations. A hell lot of function calls for something. So if you want performance, don't use Lambda for your critical kernel driver code. No. Never. These are intended to make the code look cleaner, right? So performance, interesting. What if we limited it here to 3? It would receive a 3, and then the collect would do what? Would ask for more. What will the limit tell the collector? Oh, nothing, right? Nope, I'm done. So the stream is closed, basically. In some terms, limits will kill the stream, will not process anything less. This means short-circuiting in a way. It means the stream can be, by the way, I never said that streams must be finite. You can have a stream of an infinite stream of random numbers, for example. This way, with limit, you can limit the first 100, for example. You can even write a Fibonacci stream yourself. It's very interesting as a practice. What if you would use find first here? Find first will ask for one element, and once it receives that element, it will not ask for another one. It will just terminate the operation. It will just stop the processing, return that optional, by the way. Remember, the dreaded optional. And the rest of the items won't even be seen, won't even process, and not at all. I also fear optionals in my entities, which return optionals yet. It is on my to-do list. I'll implement this in 1 week or 2 weeks time. It's right now. I want to do that. Your getters for entities to return optionals. Huh? How cool is that? I even started doing that. So embrace optional and use it. You know, when you export to a CSV file, to an export file, you somehow go through the model. And when you navigate model, you know the train wrecks, blah, blah, get blah, blah, dot, get blah, blah, right? Any null in that path, it's a lovely exception. What I do now, map, 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 or else null at the end. And I completely avoid the nulls, the null pointer exceptions. It's creepy. The code looks a bit weird, but I don't have any null pointer exceptions. Interesting. This is short circuiting. Now, what left? What is the most important principle in programming, in your opinion? Don't repeat yourself. Don't repeat yourself. Or that's the other most important principle. In my opinion, this dry and this are the most important principles. What's this? Single responsibility principle. Both of them, out of which I like most dry. So many people say the single responsibility principle is the most important principle. Right? Have code do one single thing at a time, not multiple things. But I prefer KISS. Keep it simple at all times. Keep it short and simple. Keep it simple and stupid, said the US Navy. That's the original code. Keep it stupid and simple. When the Japanese hit you with the cannons, you have to be, that cannon that you have in front of you must be trivial to operate. Right? Just aim and push and that's it. Right? Simple code. We like to say, keep it short and simple, not stupid. So keep it short and simple. Okay, these are the clean code principles, which are carved in stone, right? Short functions, 5 lines. Read the book, the Bible, right? This means, okay, I don't have 5 lines in all the application, but in the core business logic, I do. Sorry? I have, but it's a simple example. But in production code, I do have 5-liners in the business logic services. But in the outside world, there are the code which is 20, 15, but not more than 20. I know, I saw methods of 150 lines, 2,000 lines, I saw. In lambdas, this translates to avoiding multi-line lambdas. If you enter lambda, enter is not readable anymore. The indentation is screwed, it's awful. And also, out of the KISS principle, the most important is the simple part. Not short code you want. You can write short code with lambda, then you will blow everyone's mind. You can do that. But that shouldn't be your purpose, because the delivery day will come, the D-Day. Right? So have simplest form that you can write. Ask a colleague of you to review the code. This is the best advice that I can give you. Ask someone to review lambdas. Try to explain what you wrote to someone who is not proficient in lambdas, and see what they say. Right? Use expressive names. This translating lambda to using for-dots notation. I've told you. Put a name to that method, to that lambda. I hate lambdas. Right? Don't use more than 3 parameters, because you'll have a hard time with lambdas. There is no 3 function by default. Avoid Boolean parameters when you have a function which takes 3 Booleans. What will you find out of that function? Usually, dirt. No. You have 3, 4, 6, 9 actions possible. How many? 6 actions possibly happening inside. Don't ever do that. 9 actions actually. Don't ever do that. Right? A Boolean is a code smell. A Boolean as a parameter to a function is I cannot refrain myself. This is clean code, and I love clean code. Sorry, it has nothing to do with lambda on this part. But don't put Boolean parameters in your function signatures. It's a sign of adding responsibility, additional dirt. You know. Don't throw checked exception. It's bad for your health. Right? It's very bad. If you really do want to do that in lambdas, you can try this one. Encapsulate conditionals, and I'll have a quick last exercise with you. You'll see in a moment what this means. And also, don't be afraid of introducing new variables just to explain what you want to say there. So explanatory variables, just that you put a name to something, right? But this is the most important advice. Per program, yes.
For what level of complexity should we start using lambdas?
Level of complexity. Each method should be understandable in 3 to 5 seconds.
No, you said earlier that lambdas are not performing.
Complex, you mean performance. You know what Knut said? Knut was a guy that dedicated his entire life to optimizing algorithms. He was the guy, n log n, n squared log n, and that stuff. And he said, premature optimization is the root of all evil. So I don't give a shit about performance. I don't give a shit. If I measure a problem, of course, I wouldn't query. I wouldn't query the database in a loop, of course. For e to 1 to 1 million, select. I wouldn't invoke a REST service in a loop, of course. I wouldn't do absurdities. But don't think too much about performance from the start point. The sole purpose that you should have is a clean code, maintainable, readable, easy code, right? Simple code. Don't try to foresee the performance problem. Measure it. That's part of the clean code training, the performance training I have. The point is, in enterprise applications, the only performance problem that you have is usually when you do input-output with HTTP socket files. When you stay in memory, the servers are so fast, the just-in-time compiler is so efficient that you don't need to worry that much about performance when you actually write the algorithm in code. So even with Lambda, use them freely. Don't be scared of performance. Measure performance and then revert to the Java 7 way and see if what you gained works to ruin the readability of the code. That's my principle, and many argue with me on that, but I always win about that. Keep it clean for now. If something goes wrong, you will optimize it. But you should always think about possible performance problems, indeed. You should think, it's a good point. But don't mess your code just for your thought about performance. If you want to know more, just Google just-in-time compiler and see what optimizations can that tool make to your code live as it runs. It compiles memories that got hot. It's a creepy thing that goes on underneath in GSM. Just for you not to be worried about performance. Only optimize input outputs. Quickly show you this, how you can stream the lines out of a file. It's files.lines of a path, file to path. This gives me a stream of strings. You see what I'm doing here? A stream of strings that I get back. But there's a warning here. You follow what I'm doing? Huh? There's a warning. Lines is never closed. What the heck? I have a closed method on the stream? Wow, that's cool. Why? And why didn't I show the warning before? Because I wasn't streaming any input-output resource. I'm streaming a file. What would happen when you will close the file? Right? So what do I do next? I will resources, of course. I'm making Java close the stream for myself, right? The tricky part. The whole recording will be there. You have the Git source, and this is how you will automatically close the. So the bottom line: streams can be closed in case you stream from an input-output resource that needs to be closed. Right? Okay. You want to see also the check exception problem? Let me show you this quickly. So you have this little function. So a new file of list files. It's an array of files that I get here, right? And then I can stream this array. I can stream this array, and I want to transform it to map from each file to extract the get canonical path and correct to list. I want to just convert them, but it turns out that this function throws an EOI exception, a check exception. What can I do? I need to handle that exception because the map takes as a parameter a function. But the thing is that the function in Java function doesn't declare any throws. Doesn't declare throw exception. And you see, so I am not allowed to throw any checked exception from a function that I reference. So I cannot use anymore this approach. So I need to revert to the classical way. Put it in brackets. Look how ugly the code will get. To put in brackets, right? And then do a try catch here. Now that's ugly, right? That's awful. I can't even speak about it. It's so ugly. So there is an alternative way, unchecked. This is due library function, which allows me, like I did before, to reference the file for dots get canonical paths. It will actually try the exception. It's for me. It will solve the exception for me so that I can reference it like that. It will throw a runtime instead. You can imagine, right? 6. I want also one more thing. I'm out of time. Can I go fast, or you want to go to the conclusion directly? How do you prefer? Well, I want to go. You want to know? This is Sparta, right? Look. Okay, good. That's my opinion also. So dirty lambda. Just one point here. I have this predicate. I promise you that I'll tell you about predicate, cleaning predicate. Any idea how can I clean this? And where? No, I only say that this is basically one test and this one also. So instead of having and, I can put exactly the filters. It behaves exactly the same. Okay, then what next? Is before any match. What the heck is this? No, come on. This is code that I've actually taken for production, so it's renamed and all. But the point is that people actually write this code, and line status different than let's make a method just like we did before from this. So where is the lower line? E is not in stock. Public Boolean is not in stock. Which returns, what a surprise, this. Right? Don't ever invoke your getter inside, right? Okay, then line equals blah blah blah. It converts to is not in stock. I'm getting to the time limit, so in case you want to catch another stock, don't be ashamed to leave. Is not in stock, right? There is what? A networking break. Cool. I will hurry anyway. This fits in a line, but opening a stream in another stream is very ugly. I'm already in a stream and I'm opening another stream. It's horrible. So what do? I will take this part and I'll make it a method. How can I name this bit? What's the name for it? Has order, has lines, not in stock. And it receives an order as a parameter. Has order, has lines, not in stock. It's pretty readable. And then what do I do here? I hate lambdas. Why do I hate lambdas? Because it is more readable. It has a name, right? I borrow this inside. I can do even more. But how can I extract this? Now, here comes the hard part. It should have been a hard part, right? How about extract this part? How about extracting this part? What will happen if I extract this? It will extract a method which returns the predicate. Oh my God. How could this predicate be named? Has delivery date before warning date. I'm invoking a function to get back another function. And this is where we get lost, right? I'm calling a function to get back another function. Oh my God, what happened? And I can put it even static. And I can reference it using this here, or like this, or whatever. And this, I don't know, it's not very readable perhaps, but I can compose them. Pay attention here. I can do or, rather predicate. I can compose them, and I can reuse this in multiple places in my project. I can even put it in a separate class named order predicate and so on. So I can build very much to simplify the code even more. So what I want to say basically is that from this, it's too small font. I hadn't had time to simplify it, but it is actually what we did. The point is here, the conclusions. I can put the predicates as Boolean functions in the items as we did, is not in stock. We can put it in the same class we were in this 4 dots. We can put it in a separate class as static methods that look like this. It's a small font, but it's exactly what it was in Eclipse. Right. Takeaways. Well, first of all, don't abuse them. Right? I know you have just learned Lambda. Don't write only Lambda from tomorrow beginning, right? I mean, don't abuse them. Always go for the simplest form. Write a colleague of you, which stays on Facebook. Right here, ask him to come to review what you just put. See his face. Look at his pupils. If his pupils dilate, he's terrified. I'm almost serious. Or the hair on his back. No? I had reverted 2 days' work of refactoring because of the hair which raised on the back of a colleague. No kidding, no kidding. He also expressed himself verbally. But before he said anything, I saw his body language. So it was about the criteria API. But anyway, next, use suggestive names with method references. I hate lambdas, right? Don't use arrows. Master any match, and it's so infrequently used, but it's so often useful, any match. And also understand and use flat map. Read about monad. Adopt the optional, you know, adopt the GSR, adopt an option, you know, pet him, right? Don't do just get, try to use map where he's present or else, stuff like that. Work with predicates like we just saw. These are basically the references, and that's it. Thanks a lot for your time. That was all. If you have any questions.